Hello everybody! In this lesson I will discuss the theorem the adjacent angles on a straight line are supplementary, and then I will discuss 4 examples. Let's start with naming an angle. That angle over there, we can name it as angle ABD or angle ABD with a little, and I call this a copy on top of the angle that's there, or you can call it angle B1. The other angle, you can name it angle DBC or angle DBC with the copy in the middle, and also angle B2. Adjacent angles. Angles that share a vertex and a common side are said to be adjacent. In other words, there we can say a vertex is the singular for the little corner of the angle, and the plural for vertex is vertices. Let's look at perpendicular lines. When two lines form an angle of 90 degrees, we say that they are perpendicular. We use this symbol, that one, to indicate the lines are perpendicular. In other words, they form a right angle. We can say RS is perpendicular to PQ. And on a sketch, this is the little symbol that we use when we want to indicate that the two lines are perpendicular. There is also something we call supplementary angles. Two angles whose sizes add up to 180 degrees are also called supplementary angles. Angle PSR, this angle, plus angle RSQ, they are also called supplementary adjacent angles, since they share the same line, RS, and they share the same vertex there at S. There is also something we call complementary angles. Two angles whose sizes add up to 90 degrees are also called complementary angles. Angle B1 plus B2 are also called complementary adjacent angles. Now there's a theorem in maths that states the adjacent angles on a straight line are supplementary, and the abbreviation we use is angles on straight line. Now what does this mean? It means the two adjacent angles on a straight line are supplementary. That means they add up to 180 degrees. Now let's look at the example. The question says, calculate the size of B. Now when you go to the little sketch there, you can see that there's a straight line and then there's two adjacent angles. So therefore we can start by making a little equation. And the equation will be B plus 24 is equal to 180 degrees. And now, because you made that statement, you also have to always give a reason for your statement. And your reason is your angles on straight line. And then, back to your little equation over here, now you solve B. So, can you remember when we dealt with equations to solve B, we will subtract 24 on the left hand side, and what we do on the left hand side we do on the right hand side. Therefore B is 180 minus 24 B is 156 degrees. Well, now you will see that I teach this way around. With geometry, I say you have a little maths toolbox that you take with you. And now you have one tool in your toolbox, and that is angles on a straight line are supplementary. So when we do the sums now, we will use our tools in the toolbox. Example 2. Calculate the size of x. When you go to the sketch, you will find that there's a straight line, and then there's also this little thing over there. And that means there's a right angle. In other words, 90-degree angle. So where we will start is with the first theorem in our toolbox. X plus 35 plus the 90 is equal to 180. And the reason is angles on a straight line. And you always have to write that reason. And then to solve x, we will first add 35 plus 90 is 125. And now to get rid of the 125, we subtract 125 both sides so that they can cancel. What I do on the left, I do on the right. And then 180 minus 125 is 55 degrees. Therefore, x is 55 degrees. Example 3. Calculate the size of B. Now, you will find again there's a straight line and then there's 3 adjacent angles on a straight line. And then there's also a 2 in front of B. Remember, we say that's the coefficient of B. But don't worry, we will just use our tool in the toolbox. Namely, where we say 2B plus 46 plus 50 degrees is equal to 180 degrees. And the reason? Angles on a straight line. And then we solve the equation by adding 46 plus 50 is 96 degrees. And now we're going to solve B. So let's get rid of 96 degrees this side, subtract it on the left and subtract it on the right. And then on the right hand side, 180 minus 96 degrees is 84 degrees. But we don't want 2p, we want p. So how do we get rid of the 2? We divide both sides by 2. Therefore, P is 42 degrees. Example 4. Calculate the size of M. Now, when you go to your sketch, you will see that PQR is a straight line. And then there's 3 adjacent angles on a straight line. And therefore, we can say at number A, 60 plus 70 plus M plus 20 degrees is equal to 180 degrees. And the reason? Angles on a straight line, since that is your only tool in your toolbox. And then we will solve M. But first we will add 60 plus 70 plus 20 is 150 degrees. And then to solve M, we will subtract 150 on the left. What we do on the left, we do on the right. So on the right hand side, 180 minus 150 is 30 degrees. So M's value is 30 degrees. The next question here at number B says, find the size of a angle SQR. Now, where is that one? Let's look at it. Angle SQR, this is this whole angle there. And it's equal to M plus 20. So we say angle SQR is equal to M plus 20. And then in the previous sum, we calculated that M was 30. Therefore, angle SQR is 30 plus 20 is 50 degrees. In the next lesson, I will discuss vertically opposite angles. Click on the video in the left-hand corner to take you straight to the next lesson.